Hi, my name is Bryson Stemock, and I am an astronomy PhD student at New Mexico State University in the US. This poster is based on a paper that I'll be submitting within the next month or two. And what we did is we trained a convolutional neural network, a CNN, to perform some basic quasar absorption line spectroscopy. Quasar absorption line spectroscopy is important to understanding the CGM, the circumgalactic medium, the gas around galaxies, as well as the gas in between galaxies, the intergalactic medium. And by fitting Voigt profiles to these absorption lines, we can learn about that gas's rest frame velocity, column density, and Doppler B parameter. The problem with this analysis is that it can be very time intensive. Typically how it's done is a human will generate an initial model, an initial guess for those three parameters, and then feed that model to a deterministic fitter or a Bayesian fitter. And in 1 week, an expert might be able to fully analyze one or maybe two of these systems. And we have 3,500 carbon-4 systems on disk, which I estimate would take about 70 years to analyze. And since I would like to graduate sometime before then, I am trying to train the machine to do it for me. So we trained a convolutional neural network on about 1 million single cloud magnesium-2 doublets. And once we were satisfied with the results of the learning and of the training, we gave it 56 systems that had been already fit by a human who had then provided the information to a deterministic fitter called MinFit. So this is shown on the x-axis, the human plus MinFit, and the y-axis shows the CNN predictions for these three parameters: velocity, column density, and B parameter from left to right. And so we see a pretty tight fit for the column density and B parameter, and it looks like there's a bit of spread in the velocity. However, this bar right here is the pixel width, so that's just one single pixel, and so that all of that spread is just sub-pixel variation, and we're really not that concerned with it. So if we look down at the cumulative distribution functions, here we have the CDF for residuals. That's the difference between the model and the data here. We have velocity, column density, and B parameter, once again, moving from left to right. And so for the column density and B parameter, the CNN on its own does a pretty good job replicating the human and MinFit's results. However, when we look at the residuals, we find that the CNN tends to very typically underpredict on column density and B parameter, and which kind of gives us a shallower profile than we actually see in the data. So what we did is we then provided the CNN's guess as an initial model to the deterministic fitter. So essentially, instead of having a human generate the initial model, we're now having the CNN generate the initial model, and we're kind of replacing that human element there. And when we do that, the deterministic fitter kind of snaps right back to the models that it produced when a human was providing those initial models. And so what we've essentially done is we've replaced the human in this simple scenario with just a single cloud with just magnesium-2. And so this takes seconds for the machine to go through 56 systems. Most of the work and most of the time is in the training, which did take a while. That can take months. However, it still doesn't take 70 years. So this is the most simple case. We do plan on moving on to multiple clouds and more transitions, but these are our initial results. And thank you very much for hearing me out.